So A bar which is equal to AY bar which is equal to 160 into 80 into 120 minus 40. So which is equal to how much?
1.02.
1.024 into 10 to the power 6.
10 raised to 6. Okay, so this is the AY bar. Now we will find out shear stress. Okay, now we will find out shear stress. So find shear stress. Find shear stress. And already you know that how to find out shear stress. So tau which is equal to SAY bar divided by IB. So S already shear force we have calculated and shear force is 8 kilonewton. So 8 into 10 raised to 3 into AY bar is 1.02 into 10 raised to 6 divided by moment of inertia already we have calculated 184.32 into 10 raised to 6 into width. Okay, width is 160. So you calculate and tell me shear stress which is equal to how much? Shear stress which is equal to 0.276 Newton per mm square. So this is the shear stress. Now we got bending stress and shear stress. Okay, we got bending stress and shear stress. So we are able to find out principal stresses. We are able to find out principal stresses. Okay. So bending stress along x direction. So sigma x which is equal to sigma which is equal to 6.94 Newton per mm square. Okay. So bending stress along y direction which is equal to 0 and tau which is equal to how much? 0.27 Newton per mm square. So now we are able to find out principal stresses. So next step is we will find principal stresses. Find principal stresses. And already we know that how to find out principal stresses. So sigma 1 comma sigma 2 which is equal to sigma x plus sigma y by 2 plus minus square root of sigma x minus sigma y by 2 bracket square plus tau square. So now we will put value here. So sigma 1 comma sigma 2 which is equal to sigma x is 6.94 plus 0 divided by 2 plus minus square root of 6.94 minus 0 divided by 2 bracket square plus 0.27 square. So you calculate and tell me sigma 1 which is equal to sigma 2 which is equal to. Yes, sigma 1 which is equal to 6.95 Newton per mm square and sigma 2. Sandeep, mute yourself. Sigma 2 which is equal to
minus 0.01.
yes. All participants mute yourself. So sigma 2 is minus 0.01. Minus 0.01 Newton per mm square. So these are the major and minor principal stresses. After that, next question is asked, that is principal planes. Principal planes. So principal plane tan to theta. Tan to theta which is equal to 2 tau divided by sigma x minus sigma y. So tan 2 theta which is equal to tan 2 theta which is equal to 2 into 0.27 divided by 6.94 minus 0. So tan 2 theta which is equal to
0.077.
0.077. Okay. So 2 theta which is equal to tan inverse of 0.077. So 2 theta, which is equal to
4.44.
4 4.44, and theta, which is equal to, Sandeep, mute yourself, 4.44 divided by 2. So theta, which is equal to
2.22.
2.2.
2.22 degree. Okay, and theta 2, which is equal to theta 1 plus 90 degree. So which is equal to 2.22 plus 90. Therefore theta 2, which is equal to 92.22 degree. So this is the minor principal plane and this is the major principal plane. After that, next question is asked. So in that next question, you have to find out maximum shear stress. Find maximum shear stress. So how to find out maximum shear stress? Tau max, which is equal to sigma 1 minus sigma 2 divided by 2. So sigma 1 is 6.94 minus 0 divided by 2. So tau max, which is equal to
3.47.
3.47.
3.47 Newton per mm square. And direction of shear stress, theta 1, which is equal to theta plus 45 degrees. So which is equal to 2.22 plus 45, which is equal to 47.22 degree. And theta 2, which is equal to theta plus 135 degree. So which is equal to 2.22 plus 135, which is equal to 137.22 degrees. So this is the answer. Got it? So whenever you have to find out the stress, principal stresses in beam, at that time first we have to find out normal or bending stress, then shear stress. After getting normal and bending and shear stress, we are able to find out principal stresses. Okay. So please write down fast.
मॅडम ते बॅक साईडला घ्या मॅडम मार्क्स.
बॅक साईडचा लाईट गेल्यामुळे ते गेलेलं आहे थोडं. Okay. Your writing is over. over. Okay, so today we will stop here. One theoretical point is remaining from this unit number 2, stress trajectories. So we will continue in next lecture. Okay, so thank you. We will continue remaining point in next lecture. Thank you for attending lecture.